Alright, chemists, let's have a look at the solubility of ionic compounds in water. So our learning goal here is to understand how water's polarity affects its ability to be a solvent, okay? And we're going to look at that in particular with an ionic compound. So you should be able to use models, like a stick and ball model, to show how this dissolution is going to work in the end. So ionic substances tend to be soluble in water, and that's because ions are charged like water. That should say like that. And because of this, this means that like dissolves like. So ionic bonds break, the crystal lattice and the ionic bonds break apart, and we get aqueous ions. This is what happens when it goes into water. So we have aqueous ions separating out into the water instead of neutral atoms. And what this means is that the positive end, so the positive ion and the negatively charged ions, they interrupt the hydrogen bonds, and they basically get between the water molecules. Now that leads to something specific happening. And what that is the positive ends of the positive ends of the water, the hydrogens, are electrostatically bonded to the negative, so non-metal ions. And we see that over here. We can see that the positive ends of the water, these little water molecules, all face around the chloride ions. This is sodium chloride that we're looking at here. And we'll see that we get a hydration shell. And the opposite also happens. The negative ends, the oxygens of the water, electrostatically bond. So it's not a chemical bond, it's an electrostatic, it's a physical bond to the positive metal ions. So here we've got sodium against a much smaller ion, and we've got the oxygens in the water are all hanging around it, making a hydration sphere. This particular type of this particular type of reaction allows free ions to exist. So ionic compounds which are not conductive as a solid will be conductive when in solution. So this gives us an ion dipole bond. That's what this type of bond here is called, an ion dipole bond. And again, it's a physical electrostatic bond, but it's a bond nonetheless. Alright, I hope that made sense. If you have any questions, put them in the comments below, and we'll get back to you as quick as we can. Thanks for watching. Bye now.